I think this is probably about the third STEM project kit that I reviewed in my channel, because I was always thinking that, maybe I can review something which actually is going to be useful for my son, who, well, I'm hoping that, well, I think at some point he is going to be interested in programming and compute. Well, he's obviously interested in computers, but I'm thinking more like the programming side of it, not so much the playing side of it. And it hasn't happened yet. When I looked at this, I thought that it is a little bit different, because from all the other kits that I have seen, because besides containing all these various components that you can see here on the screen, it does have this additional physical appearance, which makes it maybe a little bit more appealing than anything else. So it has this, everything is built around this house that you can see here. So, it is marketed as this smart home starter kit, because, well, obviously the house and the sensors and everything. So I thought that maybe it's, that's unique. And also I do like the fact that everything is built into a sort of like a kit, so you can just pick it up and then move it around. It's sort of like self-contained, and it has batteries inside, so you can, if you have a really good program, you can burn it, and then it's not tethered to the computer anymore. But when you are developing, then it's still tethered. So yeah, that was the main thing. And you can see the kit here. So there are two different variants. So I have the Q001, which is the easy plug-in version, which sells for $67 plus shipping at the moment. And I mean, you can look at the whole thing and all the different components. Everything is listed here, and everything is nicely labeled. And you can use the AceCode, and you can also use Arduino IDE. So the AceCode is like a Scratch variant, and I do like the fact that they are providing an app for it, so it's not like a website. So you're really not connected to the internet. You can just work on this offline completely. And this whole thing comes as like a flat packed IKEA thing. So everything is in boxes and in parts, and then you have to assemble it together. And it wasn't that complicated, but probably I spent about, I don't know, maybe 1.5 to 2 hours to get everything up and running until, well, from the point that I opened the box. So as you can see, it's nicely packaged. It shows you what you are getting, and then you open the box. Basically, you have a list of different components that are individually bagged with all the accessories, which are screws and nuts, and even you got with a screwdriver and everything. So you literally don't have to get anything other than this kit. And of course, for the house, for this whole physical appearance, there are parts that are cut from, I think this is 4mm plywood. So you're gonna have to think about 4 or 5 sheets where every single part is cut out already. There are some really thin bridges that you can just break, and the individual parts pop out. All the parts are labeled, so it's very nice because they have like different labels on the parts, and then those labels also show up in the instruction, so you can tell which how they put together which part it is that you need to work with, and also the label actually shows you whether which one is the inside face or the outside face. So I think it was easy to put together. I was thinking about using glues, but the fit and finish is so good that everything slots into together, and then it's there is a certain amount of friction in the parts, and as you can see, there are some tabs as well that you have to insert sort of to interlock the different pieces together. And so I just followed the instruction. I never glued anything, which also means that if for any reason I need to take this apart, I can just take this apart completely and go back to the original state, and then assemble the whole thing together. There wasn't really anything in the assembly instruction which was difficult. Really, I just followed the whole thing. I mean, I was just physically following the build process, and I'm putting all the sides and everything together. This portal thing with the LED strip, that was a little bit difficult to put together because all the different parts, and there are some N2 nuts as well, so the things get a little bit fiddly. But other than that, it was fine. Probably the last thing, it was a bit complicated. Well, no, it wasn't really complicated to be honest. It's the wiring. So when all the sensors and everything is in place, and then you want to put basically the two halves together, first you need to connect the different wires. But again, the documentation really helps you with that. So if I show you the documentation, so you can download this whole zip file which contains everything, and then you have you know, a folder for the AceCode, and you have a folder for the Arduino, and each of them has you know, numbered folders here. So there is a one which says start here, and then you start and you open the first documentation which takes you through the basics, and then everything has this nice like sort of like a discussion thing. So you know, when I show you the documentation, like, you know, there is like a bit of story that the kids can read and understand the whole thing. And so that's basically the main document, which explains you a lot, and then it has a sample projects that you can build together. So you can see the different tasks. So task 1 from 18. But also on the other hand, there is a separate assembly instruction. So that's the thing that I followed. And you can see that everything is clearly labeled, what parts you need for individual step, what you need to put together. There is some text prompts as well, what you need to do. And as I said, right at the end, not really the last thing is, but there is this page which shows you the wiring. So you just have to go through and then see, okay, I need to plug this into here. So you just follow the lines and then plug it in. And that's it. So it's simple as that. And also here there is a page which shows you all the pinouts, which is really not required for the assembly, but it's going to be very important later on when you do the actual coding. And then, yeah, that's the end of the assembly instructions. And the rest of it is, you know, again, you have some code tutorial, and there are similar documents for the Arduino IDE. So here it explains this AceCode, basically this Scratch application, and how you use it and how you install it and download it and everything. But then there is similar part for the Arduino as well. And finally, yeah, you have the program files. So you have those 18 examples, and you can just you can build them yourself, or you can just download them, open them from here. So the one thing I was missing is that, you know, once I assembled everything, I wasn't really sure if I have done everything correctly. So there was no like a test program which is going to run through all the sensors and everything, and then it's going to show you that it's working. So I thought that that's what I'm going to build in the AceCode. So I have, let me just change the view. So I have created this code in the Ace environment. So it basically just tests everything. So it tests all the sensors, the screen and everything. But before I go there, let me just show you what this AceCode, how this one looks like. So it is, well, this one is a Windows application. And then on the top you have stuff like you can change between different languages. So you can see the supported languages. You have file options, you have editing options, fairly simple ones. And you also have some tutorials. So these are not the 18 tutorials. So these are, I think, additional tutorials. But these would, I don't think these will be related to the physical kit as well. Because, well, I'm going to show you this a little bit later. And on the top, you can select your board that you want to, connect to. So COM11. And whether you have ESP32 or ESP8266, but this is an ESP32 kit. And that's also nice. What you can see here is nice. I haven't seen this one. You can choose online mode, where basically the code is running as long as you are running this application. So this is ideal for testing and debugging. But then once your code is, you know, fine, then you can use this upload mode, and then basically you upload the sketch onto the ESP32. So you can just unhook it from the USB, and you can use the built-in batteries to power it, or the USB port to power it. And then, as I said, it becomes its own thing with the program which is, you know, running on it. So you hook it up, you power it up, and then the program that you have created runs on it. So up until now, I mostly use this online mode. So the other thing I wanted to mention is that this Scratch interface is probably like a standard Scratch interface because it has most of the things that the standard Scratch uses, as in that you build your screen here and you have sprites and controls, and you have all the different blocks for these things, which I don't think you are going to use a lot because with this kit you want to work with the physical things. So everything which up here is in the motions and the looks and the sounds, I don't think it will get used. I mean, sounds, it's going to play sound, that's going to play sound in a PC. Once you burn this application onto the ESP32, that's not going to do anything anyway. And this looks and motion relates to these sprites and things that you can move around here. You can build an application which works with the physical hardware and the screen elements as well. But I guess in some cases you would, I mean, most of the programs, most of the examples relate to the, to the physical kit only. So these things are not going to be used. And the rest of it, so that applies to these costumes and the sounds that you can see here as well. But then the rest of it, like the events and the controls, are the standard Scratch stuff. So this is how you create loops and if statements and create variables and weights and that sort of stuff. Okay, the sensing is again related to screen elements, how these if this icon is touching another icon, stuff like that. So again, probably not going to be used. Operators, that's standard operators. You have variables, you can create blocks as well. And then finally, anything which is specific to this Acebott is in the robot section, where you see the blocks for each of the sensors. And you are going to see a lot of stuff here which is not included in your kit, because obviously they are included in other kits that they are selling, but there is only one application, so this one application just has everything. So for example, MQ4 gas sensor is not included in this kit, is probably included in another kit. And now this goes back to the thing what I said previously is in this document, where you have the pinouts. So this actually tells you how you can create stuff. So if you want to create the LED module, which is the small blue LED, then you have a thing here which says single LED on and off. But then here in the single LED, you can select the pin where this is connected. So you can see, you can select all these different pins. But in our case, it is connected to pin 19. So here, when you bring this from the palette, then it says, pin 10, but that's not going to work because on our kit, the LED is connected to pin 19. So that's when this one becomes handy, because then you can, look at the EO outputs here. But I've already done this for you in this example, so you don't have to worry about that. Yeah. And then going back to my example, what it does basically is that you can see that's the main block. So when the play button is clicked, which is here, then it's going to run through this section of the code, which basically just says that if the ID is that, then run this routine, and then every routine is going to advance this test ID variable to test a different device. And that this test ID variable is incremented by pushing the button on the top of the house. So that's how you advance from basically one screen to another. And then I'm using the actual LCD screen to always show you what, where we are in the code and what we are testing. So we have from 0 to 11 all these test scenarios. And for every single test scenario, you can see the individual, these blocks here. So like the LCD screen test, it just basically creates a loop, and in that loop it looks for the wait until the button is pressed. Button 26, that's the button on the top. 26, yeah, button 26. And then let's say if I want to do the LED test, so the LED test, then it just prints the screen LED test, and then it's going to flash the LED on and off, and then at the end it checks whether you have pressed the button, and if you press the button, then it advances to the next test scenario. So yeah, it's fairly easy then. So yeah, it's a fairly easy code, and I mean, I haven't really done very complicated coding, but at least it will allow you to test everything which is in your kit, and then you can build your own code. At least you know how each of the components work by looking at the code. Okay, so I am going to freehand this part of the video presentation because yeah, that's the only way I'm going to show you. So, but before I do that, let me show you that in order to run, of course, you have the file option here. You can load from the computer, so you can load my example from the computer, and you will find the example in the video description. So you load it, and then you select the COM port once you connect it with a USB, ESP32, and then you just hit this one. And now it actually, if you see this, this section is highlighted, so you can actually see what part of the code is being executed at the moment. So it's running the LCD screen test. And if we switch now, then you can see Acebott test, press for next screen. So that's basically just testing the LCD screen that it's working, and it is working. So I'm going to press the button, and now it is testing the LED. So it says LED test, flashing light. Well, I haven't really implemented anything other than the flashing light. So click. So checking the button only works in the end of the cycle, so sometimes you have to press it a little bit longer. Okay, so the next one is the DHT11 test. Okay, so now the temperature and the humidity is showing. Because I'm refreshing the screen every time, then it flashes a little bit, but that just basically pulls the data from the sensor, which is up here, so you can validate that this is working. Oops, so if I press the button again, then we have the light sensor. Did I press it too much? No, I don't think I've done. So that's the light sensor, and I think this light sensor works the opposite way, how you would expect it, because now it shows a big number, and if I cover the light sensor, then it shows a high number, and then it shows a lower number again. So it works the opposite way. It shows a higher number if the brightness is lower. But yeah, so you just have to account for that in your code. Okay, so next one is the raindrop sensor, which is a I think it's more like a conductivity sensor that you can see up here. So you see that it has a number, and if I wet my finger and if I press on it, then it becomes a higher number. So there is conductivity on that plate. Fine, it's good. It's good for a touch sensor. Well, not exactly good for a touch sensor. It's okay for a touch sensor if you have wet fingers. Okay, so motion sensor. So that's the motion sensor that you can see up on the roof, and if I wave, then there is motion detected. And if I don't wave anymore, there is not going to be motion detected. Works like a charm. The laser module. So this has a built-in laser, which I'm not really sure if this is a best idea to give to kids. It's probably like a very low power laser, but a laser nevertheless. And then what it does, it has this peg, and then it also has this plate, which looks like just a piece of plexiglass, but actually it has some etching on it. And if you look at my ceiling, then you can see that there is something projected to it. And if I rotate this piece of glass or acrylic, then you can actually see that you can rotate it different things. So it's like a projector. Actually, this is really cool. Apart from the fact that you have to tell your kids not to look into the laser. But that's cool. And if I go further, okay, so what happened here is that now I've actuated the servo. So this door has opened, and now it's closed, and we have another door. Actually, that's the window on the other side. So that's open, and then now it's closed. So this one is a little bit tricky to do because obviously you have to configure it like, well, the way you have to configure it, you have to close the door first and then mount the gear in the closed position. So when it opens, then it can actually open, so it doesn't go the other way. and it's not going to jam the mechanism. And I found that if the closed position is 0 degrees, then the open position is 120 degrees. But that's it. So we're already on the next step, which is the RFID reader. So that's the RFID reader, and if you present the tag, then you can see on the screen that it reads the tag, the RFID tag. So you can use it for some entry validation. I have some other random RFIDs and it was not able to read that, so probably it uses some or recognizes certain type of RFID tags, but that's it. And what else? Oh, we have a portal. That's basically a one-sided mirror with some LED strips in it, and you can control the color of the LED strips. You can actually control the individual LEDs in that strip, but that's cool. I mean, it looks really cool, to be honest. What's next? Voice commands. Okay, so I think that's the piece which is not really working. I couldn't get it working reliably. So that's the voice recognition module, which is basically like a microphone and I think it's a speaker. I couldn't get the speaker working, but the microphone is definitely working. And the way it is supposed to work is that it has a wake command like hi Lumi, and you can there are a set of commands that it can recognize. So for example, hi Lumi, open the lights, and that it's supposed to recognize and give you a code, which should be like, 2 or 3. And all I can get is, I can get this to cycle these codes, but it sort of does it randomly. So, yeah, it's not really working, but I think it's a nice gimmick. But honestly, this is the one which I would be least interested in. But still, you have this voice recognition, and according to the documentation, these set of instructions are baked into the voice recognition model. Maybe you can use it for something else, but that's the only way I could validate that this is actually working and doing something. And I think by this time we reached the end of this, demo, because now we are back to the flashing LED test. So it's basically these 11 things that are included in the kit, and this is how you can use them. So I think this really concludes my review of this Acebott education kit, or smart home education kit. I think it's it's actually fun. It looks nice. I do like this fact that it is built into something, not just a collection of random components that are just thrown together in bags. I mean, of course, you can buy similar kits which have like a sort of like a rover or like a quad that you can have motors and then can move around. But probably this is a more permanent installation. But I like the fact that it has so many real life sensors, so you can actually build sort of like home automations. And some of these examples are also like, let's turn on the lights when motion is detected, or let's turn on something when the temperature is too high. So it feels like useful real life examples. And as I said, assembling was easy. Everything electronically, everything slots together. You can see these, everything uses these connectors, so you don't have to solder anything. You don't, and these connectors are either have 3-pin connectors or 4-pin connectors, so you can't really go wrong with them. Everything is directional coded. There is no colors. You don't have to match anything. As long as you can plug them in, that's what you are supposed to do. So it is easy to make sure that your electronics part is working. You can't do anything wrong with soldering or anything like that. So you just spend an hour and a half just to assemble everything together, and then you can just go straight into experimenting, try out the different codes, go through the documentation, and explore the various projects that they have given to you to look and learn. So if you are interested in this guy, there is going to be a link in the video description. And as I said, my test example is going to be also in the video description. But I think that will be all for today. Thanks for watching, and hopefully see you in the next video.